Let's end trigonometry with lesson 8.6, day 2, graphing polar equations. In this lesson, you'll definitely need your calculator. Everything just plugs in. And you'll want to make sure you're in degree mode on your calculator. So graphing polar coordinates, we don't have to worry about a particular mode for the polar part. We're just going to graph them using degree mode. What we'll do is we're going to graph lots of points, and you'll see down below I have numbers related to the unit circle. When we graph these points though, remember the order for polar coordinates is r comma theta. And you'll notice down below I have all my theta values actually typed out, which means we're going to plug in theta to determine r. We're determining our ordered pairs backwards. When we're done though, we'll graph kind of just one quadrant at a time. We're going to get some kind of unique looking shapes. We'll have flower petals, sometimes they become just circles, cardioid shapes are kind of like hearts, and there's more than that even. So it's kind of a nice way to end the year. Our first equation, graph r equals 2 times cosine 2 theta. What that means is we're just going to take a theta value and plug it in our equation, and then literally just plug everything in our calculator. If we start with 0, kind of like the beginning of our unit circle, starting with 0 means we would take 2 times cosine 2 times 0. Well, cosine 2 times 0 is just 0. 2 times cosine 0. If you type that into your calculator, or remember that cosine of 0 equals 1, 2 times 1 is 2. So you should get that even if you plug this into your calculator. Once you get the hang of it, this should go pretty quickly. Let's determine all the values up to 90 degrees. So this would all be quadrant 1. If you get a decimal, we'll round it to the nearest tenth. Plug in 30 degrees. Well, 2 times 30 is 60, and if you multiply 2 times cosine 60, cosine 60 is 1/2, 2 times 1/2 is 1. Plug in 45, again just double that, 2 times 45 is 90, cosine at 90 was 0. 0 times 2 is 0. So far we have no decimal answers here. I don't think actually we'll get any decimal answers on this one. That's kind of nice. At 60 degrees, double 60, we get 120. Cosine at 120 is negative 1/2 times 2 would be negative 1. And then at 90, double 90, 2 times 90 is 180. Cosine at 180 was negative 1. Negative 1 times 2 is negative 2. Now what we do over on our graph, notice I've kind of stretched out my circles. I went in the middle is 1 and all the way at the edge is 2. That way we have a nice big space to plot all of our values. Here's our first point, 2, 0 degrees. That means I'm going to count out 1, 2, and put a dot there. We're not rotating around the circle at all. Then I have 1, 30 degrees. If I go over to 1 and I rotate up, 30 degrees is the same as pi over 6. That means this point is going to go right here. 0, 45, well 0 means I'm not going anywhere. I'm right at the center at that pole. Negative 160, so now this gets a little unique. At negative 1, going 60 from here, remember that means we start at 0 on that left-hand side, and that's going to go all the way up to that location down in quadrant 3. So I'm going to erase that line that got there. And then our last one, negative 290. So at negative 2, I'm all the way on the left-hand side. 90 is a quarter of the way around my circle. So that actually puts us down at the bottom. So if you need to watch that again, just to kind of get the hang of where we're at. Now if I connect all 5 of those points, which says with a smooth curve, I'm just going to curve up. Oh, nope, I just erased him. Wow, that was really interesting. So 20, sorry about that. 130, there we go. Now if I connect them, it's going to kind of curve up and around like so. It's kind of a unique looking just curve right there. And that's just the first part. We've got 3 more quadrants to go. Let's try the next quadrant from 120 to 180. At 120, if we plug that in for theta, 2 times 120 is 240. 2 times cosine 240 brings us back to -1. And we just keep going, you guys. Plug in 135, 150, and 180 for theta. See what you get for your output. Then press play, and we'll plot those 4 points and connect them from that -290 location. I noticed when I found those missing values that there's some consistency with our R value. Let's see. So I got 0, 135, 1, 150, and 2, 180. That means if I go to -1, I have to rotate 120 degrees from there. That's going to put me all the way over in quadrant 4. So I'm going to put a big dot there. Let's see, where else am I going to go? Okay, so then 0, 135 brings me right back to 0. Oops, and I erased it again. Why do I keep doing that, you guys? There we go, in green. 1, 150. Okay, so this one should be a normal kind of value to plot for us. At 1, if we rotate all the way over to 150, that's way over here. And then if we have 2, 180, that's going to put us all the way on the other side of our graph. So 2 to the right, but then rotating over to 180 would put us all the way over here. Again, you'll see this really unique looking curve. What I'm going to do is continue on from this point that we last plotted in the blue. So down here at 3 pi over 2, I'm going to connect up through the -1, 120, the 0, 135, the 1, 150, and then end up at -2, 180. So right there, that's a pretty cool looking shape. But we're not done. We have quadrants 3 and 4. Go ahead and connect or plot 210, or not plot, plug in 210, 225, 240, and 270 into your equation for theta and see what you get for your R values. And then press play and we'll continue on. You'll notice at 225 I got 0, at 240 -1, and at 270 -2. And that wraps up the points all the way up to the top of the circle. So if I start from 2, 180, and I loop through the points in order using that smooth curve, we're starting to get kind of some petals happening on a flower. All right, one more round, you guys. Plug in 300, 315, 330, and 360 and see what you get. At 300, I got -1, 315, 0, 331, and 362. So as I plotted -1, 300, that put me almost all the way around back up here into quadrant 2. 0, again, puts me right in the middle. 1, 330 puts me way down in quadrant 4. And then 2, 360 brings you right back to the beginning. If we start at -2, 270 up at the top, connect through those missing or those last sets of points. Whoops, I missed that curve there. There we go. We end up with a 4-petal flower graph type thing. So here's what we want to think about when we use cosine versus sine. You'll notice that in cosine, the petals are all on the x and the y axis. So the petals are on the x and y axes. If we were to have a sine function like this, the petals would be in each of the quadrants. So they wouldn't actually be on the x and y axis, they'd be in the middle somewhere. So the petals would be in the quadrants. Our next example will have us plotting with decimals. So that'll take a little bit more time to graph, but the idea of it is similar to this one. We're just going to plug things into our calculator and see what we get. Graph R equals 1 minus sine theta. So now all we're going to do is plug in our theta value and do 1 minus sine theta, press enter and see what you get. I'm going to start off by plugging in values for quadrant 1. You do the same, press play again, and we'll see if we get a match, and then we'll plot our points together. You'll notice at 0, we get 1, 30.5. If I plug in sine 45 and do 1 minus, I get 0.3. So these values get pretty small. 0.1, 60, and then at 90 degrees, 1 minus sine 90 is 0. To plot these, you'll notice on the graph at the right, we have to use those circles in between the center at the pole and 1 and then 2. So we're going to have to approximate a little bit. At 1, we rotate 0 degrees. So that one actually wasn't too bad to start with. 0.5 is going to be halfway in between 0 and 1, obviously. And that's just going to put us kind of right up here at 30 degrees. I'm going to erase the path to get there and make that point a little bit bigger. Then it goes to 0.3. So if I think about those circles like 1/3, 2/3, and 1, I'm just going to go right to that first circle and up to 45 degrees. So we're getting a little bit of a curve to happen here. But watch this next one, 0.1 and then 60 degrees. 0.1 is just a little bit to the right, and 60 would be up in here somewhere. I know that's a little bit hard to see. And then at 0, we're just right in the center. This curve right here, if we connect them, actually isn't going to be a flower petal. So let's be careful on that. In the next round, you'll notice something unique about sine. Remember from our unit circle, sine was positive in quadrants 1 and 2 and negative in 3 and 4. Plug in 120 through 180 and let's see kind of the connection with quadrant 1. If you notice, it just reverses the order, and that's what happened with sine. Sine started at 0 on the right-hand side of the unit circle, went up to 1, and then back down to 0 on the left-hand side. So let's take a look at how to graph this. 0.1, 120 is going to be symmetrical to that 30 degree, or to that 0.1, 60 degrees. 0.3, 135 gets a little bit higher up as we go over to the left. I don't know if you can see that dot there. I'm trying to make it as big as I can. And then 0.5 all the way over to 150. So now I'm in between the two kind of circles right over here. And then if I go 1 but over to 180, it's over here on that left-hand side. So as I start from 0, 90 and connect through those 4 new points, I get a curve that kind of looks, almost looks like a bird, doesn't it? Like a bird's flying. So let's plug in the next set and see just what's going to happen with this picture. Please plug in 210 through 270. So now let's take a look what happens as our angles get bigger. I get 1.5 when theta is 210, 1.7, 1.9, and then all the way out to 2. The nice thing about these answers is they're all positive. So as we do our rotation, we won't have to worry about starting from 0 on that left-hand side. If I go to 1.5, that means I'm going to be in between 2 circles, and I've got to go all the way over to 210. So that's going to be right around here. Approximate that. Well, that's a big dot. That's all right. We'll make that happen. Get rid of that path just so you guys have an idea of what's happening there. And I'm just going to redraw that point. Where did that go? Oh yeah, here it is between, there we go, right there. And then 1.7, that'd be about to that circle that's closest to 2. And I'm going to go all the way around that circle to 225. 1.9 is super close to 2, obviously. So that'll go all the way down to 240. And then 2 all the way out to the edge, all the way around to 270. Look at that. If we connect from 180, and go around, we're going to kind of really make that curve bigger and down to the bottom. So if I can get through these points here. So we're kind of getting a curved, like almost like a pear or a heart shape happening here. All right, one more round, you guys, and then we've got this. Plot 300, determine 300 through 360, and then maybe plot those points and see if you can get this shape to connect. Here's what I ended up with. At 300, we go back to 1.9, then 1.7, 1.5, and 1. As we plot those points on our polar coordinate system and connect them from 2 to 270, we get a shape that represents what's called a cardioid, or a heart. Now, if you have sine in your equation for these types of models, your cardioid is symmetrical or can reflect on the y-axis. Notice from left to right, you could reflect it over and have the points match on itself. If we had cosine in our equation, the cardioid would just kind of translate over to the x-axis where you could flip it on top and bottom and the shape would match. Last but not least, here are just some unique looking graphs from different types of polar equations. If you have something that's just sine and just cosine, even if there's a coefficient out in front, those would just represent circles. Notice on the right, we have another kind of interpretation of a cardioid. At the bottom, we've got a huge flower petal situation happening here. R equals theta, that's an Archimedes kind of loop, and then we have more petals on the right. So these are all unique types of graphs that you could get graphing these polar equations. I hope you enjoyed that. That's our last lesson, you guys, of the whole semester and year. Please make sure to submit a picture of your notes for credit.